Distinguished colleagues, dear students, and all other colleagues from various parts of Delhi. I'm very, very happy to be here and talk to you on this occasion. And I thank both TERI University as well as the German Science Center for inviting me to share some of my ideas and thoughts. When I was asked by my friend Radu to think of delivering this keynote address, I asked him, what would you like me to cover? And he stressed on the idea of interdisciplinary knowledge for water management. And hence I designed my presentation on the basis of interdisciplinary knowledge. It's more a conceptual issue rather than minute decimal-based numerical presentation of traditional water management. When I thought of talking about interdisciplinary knowledge, I think today governance is essential for water, and that governance also has to be interdisciplinary. Once we have an interdisciplinary knowledge, we need to transform our governance, which has traditionally been very, very one-dimensional, reductionist, into a holistic interdisciplinary process. The third reason I took Himalayan rivers is probably in the Himalayan rivers, which provides India with 70% of its total river flows. It is the most important source of water. But at the same time, it is the most complex, ecologically, politically, as a source of water. So when you talk of targets of interdisciplinarity, there is nothing more challenging, nothing more complex than the Himalayan rivers. That is how I came to this title, that Interdisciplinary Knowledge and Governance for the Himalayan rivers. Now, when you talk of Himalaya, what is Himalaya? For various types of people, Himalaya is diverse. For a particular village where women go 5 to 7 kilometers to collect their biomass requirements and water requirements, their Himalaya is a circle of 5 to 7 kilometers. Beyond that, they do not know what is Himalaya. So a woman in Arunachal will not know the Himalaya in Jammu and Kashmir. This is the Himalaya of the smallest spatial sort of extent. Then slowly you come to the states. Uttarakhand knows much about Uttarakhand, but knows very little about Sikkim. Then you come to the national level, what we call the Indian Himalayan region, starting from Jammu Kashmir on one end to the Arunachal and the Myanmar border of Arunachal on the other, except, of course, Bhutan and Nepal in between. We have the Indian Himalayan region. If you go another step, at the very, very macro level, you will have a tectonic description of the Himalaya. Everything that is moving, either the Indian plate is going down and the Tibetan plate is going up, everything that is moving in this tectonic process is Himalaya. So for the village level person, Himalaya is a 5 to 7 kilometer circle. For those who are reaching the space and watching from the space, Himalaya is a tectonic sort of entity, which I will show here, and the changes are going to follow. Okay, that has come. This is the NASA Landsat image of the Himalaya. And in this one minute spot in Uttarakhand will be the Himalaya for some hardworking lady, but not this whole Himalaya. And very, very clearly, this shows the Himalayan Arc, which is on the southern side. The Himalaya that even we from Delhi know, which is maybe Uttarakhand, maybe Himachal, maybe Jammu Kashmir, maybe part of Nepal nearby. It is a narrow strip on the southern edge of the main Himalaya, which is the southern aspect of the Himalaya. So Himalaya is something which needs to be conceptualized at a very large scale, but functionally understood also at a very, very small scale. That is where the local engineering would say that if there is a good oak forest at the top of a hill, you will get good drinking water spring at the bottom of that hill. That is also understanding Himalaya. Now, what is exactly even in this map of NASA, there is no cartography. But there was at some point a need for cartographic representation of the Himalaya. This came when, in 1991, the Secretariat of the Earth Summit, that is the Rio Earth Summit, asked me to draft the chapter on the world's mountains for Agenda 21. I had to go to various mountain countries, and they said, how much of our country is mountainous? Why should we be interested in your chapter? Why should we be voting for your chapter in the Rio Earth Summit? Similarly came the question of the Himalaya. What is Himalaya? And then I was working at the International Center for Integrated Mountain Development at Kathmandu. We started a process of the cartographic representation of the Himalaya. So transferring this satellite imagery to a map. The map has come there. In my computer, I had gone back, but one step back. Yeah, this to a cartographically presentable drawing. So now we go to this map. Now from that, we decided that a mountain is an area which has altitude of 1,000 meters plus. And we outlined the area, which is the Himalaya, the dark green area. This is a very detailed activity we undertook. Within the short time, I am not going to describe all that. The dark green area is the Himalaya, of which the southern aspect is a thin arc on the southern extremity. But a large part of the Himalaya is far behind of what we know as Himalaya. We go and see the Himalayan peaks from the south aspect. Similarly, a lot of people in Tibet see the Himalaya from the north aspect. Same peaks, but north aspect and south aspect. So, Himalaya probably is the largest water producer of the world. No calculation have been made. We made some attempts. Its only competitor is the Andes. Himalaya, I'll come to the various rivers that Himalaya produces. It's also called the water tower of Asia. And you can see, if I go from the top right corner, the Yellow River comes out of the Qinghai Plateau. And Yellow River is the mother river for China. China cannot survive without Yellow River. The whole densely populated, industrialized northern China plains depend on Yellow River. And Yangtze, which is next to it, gets a little bit more water from the Qinghai Plateau itself, is now transferring through the south to north water transfer project, water from the Yangtze Basin to the Yellow River Basin, because Yellow River Basin is where the hub is, industry, even agriculture, human population settlement, etc. So then we come to the international rivers. Yellow and Yangtze are Chinese national rivers. We then have the Mekong, Salween, Irrawaddy. These are all international rivers. Then we come to Brahmaputra, Ganges, Indus, international rivers. And then we get some dry areas feeding to Amudarya. Amudarya drains into Aral Sea. And a very interesting Tarim River Basin, which is a dry river basin. It doesn't flow out. Tarim just ends like the Aral Sea. It is not a sort of, doesn't drain out into the ocean. So we have these 10 major rivers from the, emanating from the Himalaya. And they support 3 billion people today. North China Plains, densely populated. Ganga Basin, densely populated. And the total population served by these rivers is about 3 billion. Now, I would like to get an idea of when I should stop so that I can tailor the whole presentation properly. I had prepared for some 40 minutes. Okay, thank you. So the Himalayan Arc is a gigantic climatic barrier. And the large part of the Himalaya land falls within China. Almost, I would say that if you see the map, China has almost 80% of the Himalaya in terms of land. But very interestingly, very large part of the water falls on the narrow south aspect, spread over Bhutan, India, Nepal, and Myanmar. I think 90% of the water falls outside China, that is on the southern aspect. And as I have described, the 10 major rivers of Asia emerge from the Himalaya. And these 10 rivers are backbone of the resurging Asian economy. If you do not manage these rivers properly, if you do not sustain these rivers in their proper ecosystemic status, your economy will not grow. Chinese economy will not grow at 7.5, Indian economy will not grow at 7, 8, 9, whatever we are talking of. The water has to be there, and the rivers have to be there in good ecological status. This is the management objective. Now, this is a reorganized map which shows the whole river basins and the dry land in the center of Himalaya, which doesn't have any outlet for water. So earlier I had shown only the area which is blue, which is outside the Himalaya, serving the countries around the Himalaya. This is the full presentation of the river basins, including within the Himalaya. The maps are little different, but not very, very different. Now, all these maps I had taken from ICIMOD. The first map I was involved in preparing. This map is a more recent one. Now, I told that the Himalaya is a great climatic barrier, and 100 kilometers can make an immense difference, as you will see from this one, where grass is the highest product of land, and grazing is the highest economic activity. There is no greenery in the mountains, but you cross the ridge and come to the southern aspect, and you will be flooded with irrigation water. Himalayan water management has to understand that this and this are integral part, but very opposite, of Himalayan water resource system. Here you have irrigated paddy, probably 2 to 3 times, just across in either in Ladakh or in Tibet. You will not get even a good harvest of grass. Now, we have this idea that everything in the Himalaya flows from the mountains, the snow cover and the ice. Snow and ice in the Himalayan river is only important for the Indus. Here is, I have taken from a paper by Immerzil, the Dutch expert on Himalayan glaciers and Himalayan water resources. Now, you can see that Indus, the dependence on snowmelt and glacier melt is very high. Normalized melt index, NMI, is the amount of flow that is generated by snowfall, by snowmelt, ice melt, divided by total runoff minus the evapotranspiration loss. Now, if you see the mighty river of Brahmaputra, mighty river of Ganga, or very significant rivers of Yellow and Yangtze, you will not see much dependence on snowmelt and ice melt. Brahmaputra has some, Ganga has some, but Indus has immense dependence on. So this helps us in understanding the relative importance of rainwater and snowmelt water and ice melt water. And you have to distinguish between snowmelt water and ice melt water. Ice melt water mainly comes from glaciers. Snowmelt can come from fields where snow falls. Now, Himalaya is there, its rivers are there, serving now 3 billion people. And here we have someone, I think Sharmaji was telling that our population will overtake that of China. This is, you can see, very soon we will be going far above the Chinese population, which has already flattened and going down. The American population is slowly but steadily increasing, but nothing close to ours. So when we reach 1.6 or 1.7 billion people, with, in the right side, you have the industrialization level and the urbanization level, we will have to look for more and more water. And when 70% is coming from the Himalaya, probably we'll ask for 80. And that is why it is important to think of how to address the Himalayan rivers. Now, every river in the Himalaya is different. Every river in our country is different. Problem of Kaveri cannot be equated with problem of Brahmaputra. Brahmaputra and Ganga, though they are part of the same basin, their characteristics are very different. And they almost are sort of have no similarity with the Indus Basin, where I have shown that snowmelt and ice melt are dominant sources. So I will talk about the Ganges-Brahmaputra Meghna and the tremendous conceptual challenge of interdisciplinarity that this basin gives. We always look for solutions from probably outside, probably other countries, but in this country, there is a lot of work going on in the various institutes, which also needs to be read in policy making, which also needs to be recognized and internalized in policy making, because these are all work of hard labor and good quality. Now I'm talking of the Ganges-Brahmaputra Meghna Basin. The Ganges Basin, on the northern part, it is, of course, snow-bound. In the middle part, it is the mid-Himalaya, where most people live, mountain people. And then the Ganges Basin is the world's densest populated river basin. You can see the level of urbanization. So, Delhi gets water from Uttarakhand, but a farmer in Uttarakhand is denied the same water. When the new connection was made from the Ganges to Delhi, where Yamuna was flowing, but it was not adequate, obviously that water has come at the cost of someone. So the whole issue of water then becomes a governance issue. Kaveri is not the only issue of a crisis of governance. If we do not address in a holistic way every river, every sub-basin, every village, every nala will become an object of a governance crisis and conflict. So let us see the future of this basin. Before that, let me tell you that irrigation in this country is largely based on Ganga Jamuna. And this is the irrigated area. You can see it is where the Ganga flows. Then we come to the level of urbanization in the Ganges basin. You have the big sort of chimney on the left is Delhi. The big chimney on the right is Kolkata. And we have emerging chimneys throughout this basin, the world's densest populated river basin. So urban demand is going to be very, very strong, as has been mentioned by Sharmaji some time back. Now I go to the Brahmaputra, which is the opposite. It is probably the rarest populated river basin. It doesn't have that sort of industrial urban setup. It has a very rich flow in the river. Sometimes people say this is flood, but I say flood is an accident. But invariably, in the month of May and June, Brahmaputra will have water. This is not an accident. We have to really refine our understanding of floods. Flood is never an accident. It is always an accident, unexpected event. Whereas monsoon is one of the most expected process, and I call it annual inundation expected from the monsoon. It cannot be equated with floods. If you see the meaning of floods in the Cambridge and Oxford dictionary, you will find unexpected inundation of an area which is not usually inundated. We know Brahmaputra water will rise from April to May to June. Absolutely. No one can stop it. It is expected. So this British understanding of floods has been incorporated, inculcated in our whole water thinking. And we think whenever there is inundation, it is flood. I'll come to this in some details later. Now, Brahmaputra Basin, yes, the most recent, the map before this, please. Yeah, the most recent intervention in the Brahmaputra Basin is not urban water, it's not irrigation, but it's hydropotential. This is the dotted map of huge number of running into 300 to 400 cascade hydropower projects on each of the tributaries of Brahmaputra, starting from Buri Dihing in the east to Lohit, to Dibang, Dihang, Subansiri, all the way to Tista. All the rivers are getting sort of intervened for hydropower. So Brahmaputra's character is lot of water, lot of hydropotential, very few people, very little agriculture. Guwahati is the only urban center around, and lots of hydropower projects are coming up. This is the character of the Brahmaputra and management challenge. So, sustaining Himalayan rivers. In this background, how do we sustain? The south and the north aspects of the Himalaya provide crucial water supplies to China and South Asia. China receives the water from what is called the East Asian Summer Monsoon, or EASM. South Asia receives its main source of water from South Asian Summer Monsoon, SASM. And they have a very different ecological feature, both the south aspect and the north aspect. And sustaining the water systems, and I call it water systems, though this conference have the idea of water as a resource. The moment you see water as a resource, you take a reductionist, economist, project-oriented approach. When you say water as a system, you have the option of diversifying into various other areas of water, its management, its governance, its utilization, all dimensions. That is why I use the word water systems. And it needs water science informed by respective ecologies of these two aspects and water system governance strategy of the two regions, the northern aspect and the southern aspect. Now, nature of the interdisciplinary knowledge needed for the GBM basin. Now, for a holistic river knowledge for the GBM basin, it's a very complex interlinking of diverse elements of knowledge and has been emerging slowly but steadily in Asia. Particularly in China and India, this interdisciplinarization process is going on, though it is not very clearly reflected in official process of policy making. Academic world is not sitting tight. The academic world is doing its best, particularly in India, on bringing in the interdisciplinarization. And the starting point in this mixing of knowledge, I would say, is the knowledge of the Asian climate. Because climate provides water. Falling water generates the streams. Streams come to the formation of rivers. Rivers create groundwater, or streams create groundwater. And this whole hydrological cycle I do not have to mention. I'm fascinated by the issue of understanding Asian climate, and I will share that with you. The climate process, especially over the Himalaya landmass, has remained in an underdeveloped state due to many factors. One factor is the inaccessibility. You cannot have easy access to the measuring stations where measuring stations should be established, like or the harsh conditions of the measuring stations, then scarcity of well-distributed data sets. Our old data are from 5 or 6 British towns, where the towns were established for schooling of British children. You start from Darjeeling to Shimla, all the major hill stations, what we call, are basically school stations for British. And they had maintained some meteorological data. But if you see the requirement of the World Meteorological Organization for the Himalaya, a densely sort of distributed meteorological station is needed. Every 80 kilometers or every 100 kilometers square, you need one data point. And that may be at the bottom of the basin and not at the top in Mussoorie or in Nainital, where schools are. So we had to redesign. I was about 7, 8 years back chairing the scientific committee of the G.B. Pant Institute for Himalayan Environment and Development. And we had bought at great cost, at 8 lakhs per unit, automated 38 parameter climate stations that can be fixed. And that climate station through satellite would pass the data to the headquarters of the institute in Almora. But 8 lakhs per unit for covering the whole of Himalaya, Indian Himalayan region, is a very, very costly affair. But if we do not make this investment, we will not understand Himalaya and Himalayan river. So it is a slow process where investment is coming. We cannot have humans living in every of these spots where meteorological data is needed. So automation is a possibility and also probably more accurate. I leave it on that. I will show one simple process, that is, here is a small river near Shimla. Suddenly we have a flood. And this is where within 2 hours, 3 hours, this river becomes ferocious. Upstream gets a 400 millimeter or 500 millimeter rainfall. This year, the Brahmaputra flood was created by a similar, what we try to describe as cloudburst, in the upper reaches beyond Pasighat. into Dihang. Dihang is Yarlung Zangpo. When it enters India, it becomes Siang, and Siang gets another name, Dihang, before it is party to the formation of Brahmaputra near a town called Hodia. But then we all escape by saying there is a cloudburst. All newspapers say cloudburst in Kedarnath created so much problem. Not cloudburst is a journalistic name. What is the meteorological climatic description of a cloudburst? We have to understand that. And research is going on at the Indian Institute of Tropical Meteorology on how to forecast that outburst. Our agreement with China or agreement with with Nepal on flood forecasting is based on the, I call it the Danda approach. When the flood water is rising above danger level, they will give us a signal. But in 21st century, with all the satellite data, can we not say we can forecast the cloudbursts? If we know the dynamic of the cloudbursts, we should be able to forecast. And that will give us, instead of 2 hours to 3 hours of advance warning, we get 2 to 3 days of advance warning. So fantastic amount of new knowledge, interdisciplinarity is needed in this combination of climate process, cloudburst, flash flood, damage, and flood forecasting. I can tangentially get carried away, but I will come back to the topic. And why we are still not able to go into full gear forward in interdisciplinarity. And I think there is a legacy of the European origin in water management in the GBM basin as much in the whole of India. Cotton is still worshipped in the Godavari basin. What the British did in Kaveri Delta is still horrifying us in the Kaveri conflict. The transformation of a low water requiring agriculture into a irrigated paddy agriculture in the Kaveri basin, promoted by the East India Company or the British rule directly. Anyway, the modern river engineering in South Asia started with the knowledge base of British origin, number 1, Thomson Engineering College at Roorkee, number 2, Bengal Engineering College in Howrah in West Bengal. They were started by the British in 1850s, leading to the construction of the upper, this was needed for the construction of the Upper Ganges Canal, which was also mentioned. The Haridwar to Kanpur, transforming a traditional low water requiring agriculture into a flourishing Western UP. When we talk of Western UP, we always say it's an agriculturally advanced thing. What made it agriculturally advanced is originally the Upper Ganges Canal, which started from Haridwar, but its technical root is with the Thomson Engineering College in Roorkee. But can British education be totally tuned to the Indian condition? Here is the rainfall of Delhi and Oxford. You can see that Oxford never has seen the type of peak we get, which was Sharmaji very correctly said that this is a different game. It is absolutely lean into, I call it the vertical hydrograph of South Asia, whereas the other one is a horizontal hydrograph of Europe. A hydrology which is based on a horizontal hydrograph will find understanding and responding to the vertical hydrograph of South Asia very, very difficult. It is possible, but very difficult. Within the short time, I will not go into details on explaining this. There are a number of books which can be made use of. But the nature of interdisciplinarity knowledge, I'm now going from the precipitation to the falling water links climate with terrestrial ecology. When we have the water falling, the terrestrial ecology, and that hydrology based on the Himalayan ecology is needed but has not emerged yet. Very interestingly, I'll come to that in a few minutes, the interaction of the falling water with the terrestrial landmass on the Himalaya. The fiercest of the rainfall in the world, called the monsoon, the youngest of the world's mountains, called the Himalaya. And the result is not necessarily water, but also sediment. And the traditional hydrological concept of rivers is of a stock of water to be transferred and utilized, especially for irrigation, and more recently for hydropower. In the ministry's presentation, you have seen rivers means cubic meters of water. There is no reference to sediment. Yet, when it comes to a crisis, Nitish Kumar says sediment in Farakka barrage is causing floods in Bihar and UP. So, we have to rethink our understanding of water. Water is not only a liquid. They are products of four things: a liquid, which is water; a solid, which is sediment; third is another element of energy, because Himalayan river has very high amount of energy; fourth is biodiversity. You tinker with one, you affect the rest of the three. You reduce the energy, sediment will drop in Farakka barrage. And then Mamata Banerjee will say, no, we have not done anything. Nitish Kumar will say, you have done everything, and Farakka barrage should be removed. Earlier, it is only the East Pakistan and later Bangladesh political leaders who said Farakka barrage should be removed. Now, a chief minister of a state says Farakka barrage should be removed. What a crisis. What a conceptual crisis. What a governance crisis. It is all because we never considered sediment as part of the presentation we saw. It is all cubic kilometers of water. Yellow River has 200 kilograms of sediment per ton of water. Brahmaputra is the world's largest carrier of sediment as one river system. Ganga, Brahmaputra, Meghna put together. And we do not consider sediments very much. The moment we change the energy or the sediment, our fish population, our aquatic biodiversity is going to be affected. Because fish needs a particular type of sediment to survive and their habitat. So it is a very unique mixture of these four elements, which is river. And river is not necessarily that cubic kilometer of water. Now, immense problems in water governance engulf if ecosystemic perspective is absent in the policy making and engineering design. The geomorphological dynamism of the GBM basin cannot be fully understood without knowledge of the ecosystemic processes and ecosystem services. I will give a few examples how dynamic the geomorphology of the GBM basin is only because of that immense sediment it carries. Sediment starts from the origin. This is Surajkund at Gangotri. Is this water, or is this sediment, or is this energy? Or is it all put together? You cannot have this only in cubic meters. You have to have this in the energy it is carrying. You have to have this into the kilograms per ton of water sediment it is carrying. If you ignore that, at the end of the basin where Sundarban is there, this sediment-laden water is coming from the Himalaya after centuries of transiting through the river basin. Their character will change, and Sundarban's character is changing. if you still do not respect sediment, you will have a coastal crisis. This is the submerged coast which goes all the way up to the equator. The visible coast is one, but sediment creates those coasts. Whole of Bangladesh, part of West Bengal, the Ganga Basin Delta is built upon sediment carried by the river. And this is a very interesting topic today because when the seabed sea level is rising because of A, heating up of the ocean, and B, melting of the Himalaya, and encroaching into land, we are losing land, salinity is increasing, and there is a policy crisis in the Sundarbans. There is a report on the Sundarbans which Dr. Nilanjan Ghosh and several of us have produced, a strategy for the Sundarbans with economic analysis. But if we do not consider silt, we are absolutely off the mark. We will be. Now here comes very interesting map of James Rennell, India's first Surveyor General. We all see today that Brahmaputra and Ganga meet and then they come down. Here, Rennell's map of 1750 to 68 shows Brahmaputra never meets the Ganges. Brahmaputra goes to the Bay of Bengal independent of the Ganges. And then there was a, I think, earthquake. There was a tremendous debris flow. And Brahmaputra moved about 200 kilometers to the west and meets the Ganga. Padma is born out of this meeting. And then Padma comes to meet Meghna. A river like Brahmaputra moving a distance of 200 kilometers over time, no engineer of the traditional European route will have ever faced this challenge. There has been a lot of work on the issue. I will stop very quickly, but it's fascinating to discuss these. This is the other fellow. This is the Yellow River. Yellow River stopped flowing into the sea because of extraction upstream, because of sedimentation downstream, because once you take the muscle power from the river, yes, this is the Yellow River. And you can see the sediment presence is so clear, it's omnipresent. 200 kilograms of sediment in the flood season in Yellow River per ton of water. Normally it is 30 kg, 40 kg, but in the flood season it is 200. This is the peak period. Now, thus the need for interdisciplinary eco-hydrology and the emergence of integrated river basin governance. Knowledge of the links of the surface and groundwater from the uplands to the coasts is an important element. This complete linkages from the upland to the coast is not part of our project understanding, design, and assessment. Our projects are measured with a 10 kilometer radius. That environmental impact assessment stops at 10 kilometers. Strategic environmental analysis at the river basin level is hardly followed. You can go and see the website of clearances of water projects. They're all with a 10 kilometer radius, whereas what you do in Upper Brahmaputra in Siang will affect the Sundarbans about 2,000 kilometers downstream. Now, the degree of interdisciplinarization needed is immense, not only across natural sciences or river engineering. I have talked mainly of science and engineering so far, but also across the social aspects, the policy aspects, the economics of water, in the absence of which water conflicts are bound to get generated. There has been a lot of talk on Farakka. Let me say on the Kaveri. And Kaveri is not a scarcity-related conflict. Kaveri is a pure economic conflict. There is no other ecology in it. There is no water scarcity in it. It is a group of farmers upstream in Karnataka and another group of farmers downstream in Tamil Nadu. Both want to have lavish paddy cultivation. So there is conflict over water. It is not related to scarcity, and I think later we will have presentations on this. And we have conflicts from Ganga to Narmada to Kaveri. Dr. K.L. Rao thought of linking Ganga to Kaveri by water, but we have linked Ganga to Kaveri by conflicts. Everywhere there is a conflict. And this is where we have to shun our very narrow traditional approach to rivers and come to interdisciplinarization. And there is enough process of knowledge making going on in this country. The challenges in water governance, the challenge related to, I'm now talking of the governance part and not the engineering and science part. Both need hours to get elaborated, the whole issue of governance. But within the available time, I touch upon some aspect of the challenges in water governance. And I'm very happy to say that I'm talking to, at the TERI University campus, this new academic area growing is of, just one more minute, on water diplomacy. The first major academic program of water diplomacy was started at the Fletcher School of Diplomacy in Tufts University. I was involved in designing that project. I was involved, even today, I'm as a member of the International Advisory Committee of water diplomacy at Tufts University. I do not know whether in the non-English teaching, English-speaking universities, water diplomacy type of projects or concepts or courses have come up or not. I would very much like to know, and I hope they have come up. And I am sure the TERI University the activity will also become water diplomacy oriented. It is not diplomacy a la diplomats. It is diplomacy for diplomatically solving water crisis. And water diplomacy is from the knowledge of engineering to the knowledge of economics, to the knowledge of botany and life sciences, to everything is packed into an academic program. And this is my last one, and the social dimensions of water and climate change is very important in water diplomacy. The Institution for the Cooperation in Water Governance and Conflict Resolution, ecological economics of water system and valuation of ecosystem services, requirements of good ecological status of water systems. Now, we all know that our cognitive root of engineering is from UK, but UK has gone far into the framework, Water Framework Directive of the European Union, where the objective of water management is described as maintaining good ecological status of water systems. If you see India's water policy, the objective is using it for national interest. That use and sustenance, the emergence of the British thought through European Union from the traditional use concept to sustaining concept is what sustainable water management should be. Now, I cannot but stop before talking the immense danger. India may have signed the Paris Agreement, but its solution is coming 250 years later. What should it do tomorrow? This is the temperature that has increased in Tibet, and this is not a forecast. This is the actual temperature which has increased, and on the right-hand margin, you will see 0.3 to 0.4, not per century, it is per decade. It's actual data with altitude. So Himalaya is vulnerable much more to climate change, global warming and climate change. And our source of water is Himalaya. If you want to address that futuristic challenge, you have to understood climate change in the Himalaya. And what is happening that the black one is the declining stock of ice in the Himalaya. All the mountain areas of the world have been taken. Somewhere it is growing. But the black one is the Himalaya and it is declining. So I leave you with this challenge of climate change in an area where interdisciplinary is waiting for about a century to be put into practice. Thanks for your attention.